All right, we're going to take a look at how to use a circle to model a real-world situation. A city wants to honor hometown veterans with a new memorial statue in a local park. A grid map of the park shows the statue centered inside a circular fence of radius 5. Two spotlights are shown at points 2, 2 and 10, 8 on the map. They are at the endpoints of a diameter of the circular fence. So we can see in the picture, here's our statue in the center of a circular fence. And we've got spotlights. You've got one here at 2, 2 and one here at 10, 8. And they are shining lights onto this beautiful statue in this park. So what they did is they probably took a map of the park and laid a grid over it so that they can do some math to get some exact measurements on where things should go. So what equation represents the graph of the fence on the grid map? So we're going to need to know two things to write the equation. We're going to need to know the center of the circle and the radius. So we'll start by finding the center. Step 1, find center. Okay, so the center of the graph, we can't just like count it. We want to find the exact center. What if it's at a 0.5 and not just on an exact spot? Like we can't estimate it. But what we do know is that these two spotlights form a diameter. And the center of the circle is halfway between those two spotlights. So what do we call a halfway point? That is going to be the midpoint. So we're going to find the midpoint of this segment right here, which is the diameter of our circle. So midpoint, let me remind you the equation for midpoint is we add our x's, x1 plus x2, and we divide them in half to find the halfway point. Then we do the same thing with the y's, y1 plus y2, and we divide those in half, and that's going to give us a new ordered pair for the midpoint. And the midpoint is the center of our circle. So x1 plus x2, if we grab the x's from our ordered pairs, we get 2 plus 10. We'll divide that by 2, and then we're going to add the y's. We have a 2 plus 8, and we'll divide that by 2. 2 plus 10 is 12. 12 divided by 2 is 6. 2 plus 8 is 10. 10 divided by 2 is 5. So we have the center of the circle, 6, 5. The other thing we need is the radius. Now, we could find the radius mathematically. Now that we know the center, here's the radius, we could use distance formula. Maybe I'll just throw the distance formula up here in case we need it in our homework. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. It's also possible that they gave us the radius in the problem. So let's just scan the words again. A grid map of the park shows the statue centered inside a circular fence of radius 5. Well, they are saving us some work because they gave us the radius. So radius is equal to 5. So this is our h and our k from the center of our circle, and we can write our equation. Standard form for center or for an equation of a circle is x minus your h, which is 6 squared, plus y minus the k, which is 5 squared, equals the radius squared. The radius is 5, so we're going to square that and get 25. And there's our equation of the circle. So we've got a follow-up question, as we usually do with word problems. An information kiosk is planned. One possible location is represented by the point 91 on the map. Should the kiosk be here, or should it be moved so as not to interfere with the fence? Support your answer. So we kind of want to know this point 91, where is that in reference to the circle? Is it on the circle? Is it inside the circle, outside the circle? All that good stuff. So what we can do is we can check the point 91 in our equation and see how it works out. So we're going to plug in the x and the y. So our equation is x minus 6. We're going to plug in the 9 for x. So 9 minus 6 squared plus the y is a 1, so 1 minus 5 squared. We want to know, does that equal 25? So 9 minus 6 is 3 squared, plus 1 minus 5 is negative 4 squared. 3 squared is 9. Negative 4 squared, remember when we square things, they turn positive, so it's a positive 16. And 9 plus 16 is 25. So what we figured out is we plugged in a point to our equation and it worked out perfectly. So that means that that ordered pair, 9, 1, this is on the circle. And in this case, the circle is our fence. So if we put an information kiosk on the circle, it is on the fence. And we're not going to do that. So we supported our answer. 9, 1 is on the circle, so it would interfere. It should be moved.